Hi, everyone. My name is Jan Schlechta. I'm a senior data engineer here at CloverDX. And today, I'd like to talk a little bit about architecture, data projects, and some principles that we believe might be interesting to our clients. Of course, we could talk about many of the principles and many good practices, and the list here would be very long. But there is not enough time on this webinar, and so we really wanted to focus on, say, the most critical ones and those that many of the projects that we came across actually struggle with. So these are breaking down complex processes into smaller, more manageable pieces, avoiding duplicate functionalities, consistency and staying consistent throughout the project, data quality principles, and some more notes on the documentation as well. So why do these matter? First of all is the maintenance over time. Nowadays, it's not the computing power or anything like that. It really is the maintenance over time and long-term, say, that is the critical factor for say success of the data projects. You will need to make sure that the process that you will develop nowadays will actually work in a year from now, and then that you will also be able to extend it at some point. The other thing is the trust in the process and in data it produces, because the data is there to support your business. So it's good to stay transparent and make the pipelines that you will develop understandable by the entire team. It'll also help to make the process complete, so you will not forget about some items of the process or some elements in the process that you may eventually forget if you were only focusing on the data part of it. So let's start with the first one, breaking down complex process into smaller, simple elements. The reason why we're focusing on this one is probably the maintainability in the long term. In the first place is the completeness of the process, development team productivity, right? Because if you have one big chunk of a code, it's really difficult to stay productive on the development side. So breaking the things to smaller pieces will allow you to split the work and be more productive. Also, the smaller pieces will allow you to cover the entire process with more tests. And so you will build more robust solution, which in turn will result in increased trust in the process and, again, the data itself. I'd like to share some of the real world issues that our clients shared with us. So on the maintainability note, it's the complexity of the job, right? And it can happen that maybe one of your developers who designed a job has left the company, or it's just too, the process is too old and no one actually remembers what is going on in it. And you need to extend it, right? So make sure it's not complex and break it down. It's about efficiency or productivity. If you have one big piece, you need to actually break it down to parallelize the work, or completeness, right? If you just focus on the data part, you may forget about the other parts like the automation and orchestration, logging, and things like that. Sometimes what happens is that our clients also report us that their pipelines unexpectedly break. And that's, again, because they have a large chunk of a code that is really difficult to maintain and really difficult to cover with tests. With smaller pieces, again, we can better test and do all the unit tests on the individual simple pipelines. So how to break the job into smaller pieces? First of all, we should keep in mind that large jobs are a typical sign of a bad architecture, right? It's probably number one sign that we can identify when we're looking at the architecture and we're supposed to say whether there is something to improve. If it's big, if it's large, it's typically bad. Another sign of such architecture is that these jobs also deal with more concerns or responsibilities. That's another bad pattern, say, or bad practice that we're trying to avoid. We can take a look at this process here that is highlighted on my presentation, where we can see that we're trying to transfer the files into the cloud and into Snowflake, and then maybe build some models for our reporting. Some might say that this is already broken down to smaller pieces, but the fact is that it is not, and we can go further. So we should actually look at each of these individual steps and try to break it down to small, simple, more manageable and testable pieces that will deal with one responsibility or concern. You can see on this example of the logging here, of the logging functionality, that you can actually drill down and just create more and more details and just really focus on one task at each data pipeline. How do we usually approach this, say, process is that we start with asking questions. There are a lot of questions that you will probably ask. It's not just a list that I have here on the on the monitor, but it's important to ask these questions. It will help you to identify, say, the patterns and reusable pieces that you can afterwards use in your data process. It'll also help you not only to find the repeatable patterns, but it'll help you to find separable patterns. And I'm going to show you a few more examples here. So the first one is on the, say, reusability. So you should try to avoid copy paste by building and reusing jobs that can be configured, right? Like this, in this example is the logging. We can, maybe in this original pipeline, that really deals with just execution of a certain data process. And the goal and responsibility of this pipeline is really to execute the process and make sure it is correctly logged and say orchestrated. We can still go into more details by employing these reusable pipelines. This is, by the way, how we do the pipelines in CloverDX. And another example of that is this not already or not directly reusable pipeline, but a pipeline that is separable from the original pipeline. If we had it in one process, you can imagine how complex it would be, because we would end up with a really large job that would be not only difficult to read and understand, but it would be difficult to extend and test. So we should try to avoid duplicating functionality. I already touched it a little bit on the logging example, but there are many reasons why we should do that and how we can do that. From the reasons, it's first of all the standardization of the process. So you'll stay consistent. It'll increase developers' productivity, which will decrease the costs, so increase the turnaround and the trust in the entire process, and will reduce the, consequently the cost of the business processes. Everything, all the values or all the goals that we're trying to reach by reusability will have its impact on the reduced costs. Excuse me. Some of the real world issues, again, on the productivity, there is no reason why you should have, 80 jobs if you have 80 data sources, if it's a single process. If it's always the same process for all the 80 data sources, there is no reason why to create 80 jobs or 80 data pipelines. When it comes to consistency, here the customer had a problem with auditing because they approached the auditing functionality in their complex pipeline, different ways. So it's better to actually stay consistent again and make only one definition of the task. So how we do that, or how we approach it, is that we try to employ what we call modular design, or it's essentially what it sounds like. In this process, we can see that we have, again, like we read some data from some data source, and then we do the expensive business logic, and then writing it or delivering it to the target data system. If we wanted to use another data source for exactly the same process, we don't have to create a new pipeline or repeat what we have already built. And instead, we can just, plug in a either different data source, or we can have the original pipeline configurable. So there are more ways how we can approach that, but there are a lot of options how the reusability and the modular design can be used. Another situation would be that we have a source that we used in one pipeline, right? We know that we had to do some data quality checks, some validation, some more tasks with that, filtering and maybe some aggregations and so on. Well, if that's the case, why would we have to do that again if we want to use it in another pipeline? There's no reason for that, right? So we would reuse what we have already built to treat the data source, and we would just plug it in a different pipeline. Now, in CloverDX, we approach it exactly this way. So we create a reusable, what we call component of the data pipeline, and we use it in multiple different pipelines. So in fact, under the in the detail, if we drill down into this component, we would see another pipeline. The pipeline is shared across these other pipelines. So again, it's the modular design that can be reused in your projects. Now, the other principle is consistency and aiming for consistency. And the reason why we strive for consistency is to help understand the data jobs among the team. Will also help prevent data issues and will help you to identify errors easier, and especially help afterwards to meet the very tight SLAs. Some of the real world issues, again, on the data quality. If in the process is some sort of dynamic mapping, and this was a case of this client, they had a very nice generic automated pipeline, but they didn't introduce any conventions. And as a result, they ended up with data quality issues that were in fact silent errors, identified months later. So they had to afterwards fix the data later using another process, which resulted in an extra cost and bad decisions based on the data along the way as well, or during the time. On team productivity, the team and another client was spending days fixing the conflicts in their repositories, and they had a lot of problems with the teamwork just because they didn't set any development conventions. Sometimes there are also problems with consistency. So each developer will approach the task differently, and afterwards it's really difficult to monitor it in production. For anyone who will monitor the production environment and the production jobs, it'll be very helpful to actually see and understand quickly what's going on in the pipelines. So to address these issues, we recommend to define conventions. Those might be naming conventions, documentation conventions, development conventions as well, and they are very important. But defining conventions is not always enough. You should also set the expectations and provide a training for that. That applies, for example, to the development conventions, where you need to ensure that the entire team will actually follow what you have defined. Next section is about the data quality and how we manage the data quality. Before we actually talk about how we manage the data quality, we should think about what the data quality matters to business. In this case, that data always means increased costs. It can be due to creation of, say, the data fixes or fixing the problem that was caused in the target systems. We may pay additional or some penalties for, some business related problems with the bad data. We can even lose the business. So we do the data quality to provide accurate data to support the business. In this case, we're trying to increase efficiency of the data process and make the process also adaptable and recoverable from the data issues. There are a few real world issues again that I have on the slide. Typical one are distort data reports. So because of the bad data quality checks or insufficient data quality checks or even missing data quality checks, the business could run the business can run on bad data. So it can produce the wrong sales results as a consequence. It can also result in unable to deliver because like in this case, the client told us that we have identified an issue in the pipeline, but we can't fix the data as we don't have stored the source data. The source data was from the transactional system, and now it's nearly impossible to create a fix for that because the data is forever gone. Another time, the data quality checks are too slow, and this is another say point of view how we can look at the data quality. Doing the data quality may not be enough because sometimes you may actually need to think whether it is worth it. Sometimes you can just do it a little smarter. So maybe, here the client was asking, should we remove the data quality checks? The answer typically is no, but do it slightly better or more efficient. So the principles are that we should always consider that a data quality is poor. It doesn't matter whether you read from or you ingest the data from a very reliable source. We should always keep in mind that the requirements on the data quality on the source system is different than the requirements on the data quality on the target system in our pipeline or in our process. And so we should make sure that we will write down the data quality requirements and we'll address these for our needs. We should validate or do the data quality and validate the data as soon as we can to keep the SLAs and to reduce the downstream burden. We should also avoid unnecessary validations or maybe minimize them. An example could be that the client that I was talking about on the slide before, they were actually reading the entire file just to check the structure of the file. It's not necessary, right? Because just to check the structure of the file, it's just okay to read one of the lines. You don't have to go through the entire file. So thinking about how to actually do the data quality, how the process can be more efficient can help a lot to the process. And good thing is also the reusability again here. If we have validation rules, maybe we should reuse them. Not only it'll keep us more efficient, but it'll also make us more consistent. One thing that many people forget about, but it's very important, and it was also in one of the real world issues in my list, is keeping source data. Oftentimes you pull the data from transactional systems, and once you read it, once you acknowledge these records that you get from these systems, the data may be forever gone. So if it's business critical data, it should be stored somewhere for sure. If maybe if you don't deal with that much big data, then staging or storing some the entire data set or delta sets, delta source could be helpful and very valuable. The last section is about documentation and why the documentation is important. Why did we put it on the list is because the process evolves over time, and the people leave, people forget, but the code stays, and so you should be able to understand the process even after many years, or maybe sometimes months is enough, right? If you develop something big and the people will leave, you need to make sure that someone who will come afterwards will be able to understand the process and continue. So the documentation, how we approach it is that we try to build smaller jobs. That's number one. That kind of relates also to the first principle, to breaking down the complex process to smaller pieces. So if we do that, we automatically get smaller jobs that are easier to understand. And sometimes, like in CloverDX here, you can see it's self-descriptive and self-documenting. So you don't have to write actually additional notes. You should also document wisely and to the point. If the documentation, or if you're in a pipeline that only responsibility is to say log information into a database, then we shouldn't be talking about anything like orchestration or how the logging would work in an orchestration pipeline and so on. That's completely irrelevant. We should only focus on what is directly in that pipeline. We should also pay special attention to interfaces and those jobs that are reusable. So in those reusable jobs, the interfaces are what the other developers will use. So it will help also the teamwork. And lastly, we should set some documentation conventions. It's good if you have, say, consistent documentation and not only the code throughout the project and the entire process, because everyone will afterwards be able predictably read and therefore understand what is in the pipelines. So just to recap what we covered today, it was the principles, the key principles that we believe people sometimes do not pay too much attention to, like breaking down complex processes or duplicating functionality, consistency principles, data quality, and documentation.